Assalamualaikum and hi everyone, this is Dr. Shazira. In this video, we are going to be solving a nonlinear equation using false position method. Consider this example. Okay, so first of all, we need to form our fx, okay, because in this example, the fx is not given explicitly, okay, but we can see from this nonlinear equation, we basically can form our fx, okay, so fx need to be equal to 0. So in that case, then we have cos x, okay, minus x cubed equal to 0. So therefore, we know that our fx is somehow cos x minus x cubed, okay, and the interval, okay, that is given to us is 0.5 and 1, and remember the false position formula is given by c equals a fb minus bfa over fb minus fa. Okay, so we are going to solve this problem using a table and calculator. Okay, so in our calculator, we need to store, okay, these two formulas. Okay, so the first one is fx and the second one the formula for the c. Okay, so in our calculator, what need to be set, okay, so the first one, okay, we want to store the equation fx, okay, so we are going to have cos x minus x cubed, the first one, and the second formula is for the c, okay. But in the calculator, we don't have this kind of notation, okay, so we will denote fb and fa as d and e, okay. So in the calculator, we will set c as a d minus b e over, okay, so fb is d, so d minus e. Okay, so now look at the calculator. So the first formula is cos x minus x cubed. Okay, so we have cos, then we have x here, x cubed, okay, minus, x, okay, minus x cubed. Okay, press equal, and then AC button. Okay, so now we have stored the first formula. Okay, so the second formula is AD minus BE. Okay, so we have a fraction here. So at the top we have alpha A, okay, correspond to our small a in the formula of false position. And then we have D, okay, minus B E over D minus E. Alright, press the equal button and then AC. Okay, so now we have stored the two formulas that we will use, okay, in our computation later. Alright, so now from the table, okay, that consists of A, B, FA, FB, C, and so on and so forth. Alright, at the first iteration, okay, r equal to 0, we have A naught. Okay, so A naught is given by 0.5, B naught is 1, okay, given by the problem. So first of all, FA, okay, so we need to use the first formula that we have stored earlier. So call back the formula 1, okay, so use this up arrow button, okay, find the first formula, press the calculate button, okay, and then we want to find the value of f when x is 0.5, okay, so we have x equals 0.5, then in 4 decimal places we have 0.75 to 6, okay. Similarly for the FB, okay, we press the calculate button, but now our x, okay, is 1, okay, which is our B. So x equals 1, then we have negative 0.4597. Okay, and then we need to compute the C. Okay, so C basically comes from the second formula. So call the second formula. Okay, so this one. And then press the calculate button. And our A, okay, correspond to our small a in the table. So we have 0.5. And then D is FP here. So look at the table. And D equals negative, okay, 0.4597. And then B is 1, and E is 0.7526. Okay, so that's our C. So C is 0.8104. Okay, and for the FC, we need to go back to the first formula. Okay, this one, press the calculate button and input our X, which is our C. Okay, so 0.8104. Okay, so we have 0.1570. Okay, so look at this stopping condition. Okay, so we need to stop the iteration if we satisfy this one. Okay, so we can see this column correspond to the FC. So look at the positive value of this. So this is 0.1570, which is way greater than this given epsilon here, 0.005. Okay. So we need to proceed. Okay, it means that we need to have I equals 1. Okay, but before that, we need to decide. Okay, we need to know whether A or B need to be changed. Okay, so what need to be done? So refer to the algorithm of false position. Okay, so you can see you need to see the sign for FA times FC. Okay, so in this case, FA is positive. FC is also positive. So FA times FC is positive. In that case, okay, if it is positive, then we'll choose the right interval. So the right interval means A need to be changed. Okay, so A need to be changed. So we replace the previous A with the current C that we have. So 0.8104, B remains. Okay. And then FA is basically our FC previously. So this is 0.1570. Okay, so FB remains. So negative 0.4597. So we need to compute the new value of C. So go back to the second formula. Okay, so press the calculate button. So our A now is changed. Okay, to be 0.8104. Okay, D somehow remains. Okay, so just use this button. B also remains, and E is FA, so new value 0.1570. Okay, so now we have the new value of C, which is 0.8587. Okay, with that C, we need to find FC. So find this formula, press the calculate button. Our X is C, so 8.8587. So our new FC is 0.0202. Okay, so the absolute of FC now is still way greater than this value here. So we need to proceed to the I equals 2. Okay, so now look at the FA times FC. So again, FA is positive, FC is also positive. Okay, so it means A need to be changed. Okay, so we take the previous value of C, or our current value of C, so 0.8587. B remains. Okay, and we need to proceed accordingly. Okay, repeat the same process until you see the absolute of FC here is less than 0.0005. Okay, so you can proceed on your own and you will get these solutions. At the iteration I equals 3, you can see you will have, FC is 0.0002, which is less than the given epsilon. Okay, so we can say that the absolute of FC3, okay, equals 0.0002, which is less than 0.0005. So it means we can stop. Okay, and don't forget to write down your final answer. Okay, so therefore, the root or x star that we wish to get is approximately the latest C, okay, that we have in our table, which is C3, okay, that is 0.8654. Okay, so this value C. So that is our root. Okay, for fx equals cos x minus x cubed. Okay, so that's how you use table and calculator to get the root of a nonlinear equation, okay, using the false position method. All right, thank you.